Today we're going to complete our last episode under the heading of land and water resources. It will also be our last episode in the topic of environmental science. And in this last episode, we will be focusing on shared natural resources. We'll in particular take a look at fisheries, but we'll cast fisheries in a more general kind of a light also. So let's begin with this topic of fisheries. By and large, when we're talking about fisheries, we're talking about ocean fisheries, although there are indeed some important freshwater fisheries around the world as well, associated especially with large lakes. So, for example, the Great Lakes in North America are important freshwater fishery locations. Now, when we talk about fishing, we have to talk about what kinds of techniques we use to catch fish. And commercial techniques are rather different from recreational kinds of techniques, because in commercial fishing we need to catch a large number of fish with the least amount of effort, so we need to be very efficient in our fishing. And there are various kinds of techniques that have been designed for different types of fish. So long line fishing is one kind, where you can have a very long fishing line which is baited periodically along its length with hooks. And you can see this kind of a arrangement in this image here. These diagrams are all from the National Marine Fisheries Service, which is a constituent of the National Oceanic and Atmospheric Administration. Another kind of technique is that of the drift net, which is a very long net which, as its name suggests, drifts in the ocean, and it is designed to entangle fish in it. Still another technique is the purse seine, which is a purse-shaped kind of a net, which is set out to encircle fish. And so fish that move into an area where a purse seine is set can then have the purse strings, so to say, closed, and then they are inside of this device, and you can see an image of that here as well. Another kind of approach is called the trawl bag, which is a funnel-shaped kind of a net that is dragged along the bottom of the ocean, generally more shallow portions of the ocean associated with the continental shelf. And this is a technique used for catching especially bottom-dwelling fish. Before we move on to the topic of harvest, I thought I should tell you what this fish is that is in this image here. This is a lionfish, and lionfish are species that live in coral reef areas of the tropics. They are native to the Pacific, and in the Pacific there are a number of different species. More recently, however, they have been introduced into the Atlantic and have become a problem in tropical regions of the Atlantic because they are voracious predators and have been wreaking havoc on places like Caribbean coral reefs, feeding on many of the native species that occur in these Atlantic Caribbean coral reefs. There are now attempts underway to control these introduced species. In their native range, they are a component of the community, and so they don't build up to huge numbers. But as is often the case with introduced species where they're introduced into a new environment without the predators and perhaps diseases and other sorts of controlling factors that we find in their native range. They build up to huge populations. They undergo exponential population growth and so cause problems for other members of the system. So now let's turn our attention to the topic of harvest. The rate at which fishes and other marine organisms are being harvested has been steadily increasing. This is an image of what the present harvest is, or within the past 15 years or so harvest, within U.S. waters. You can see that much of the United States harvest comes from Alaska, in the Bering Sea and around the Aleutian Islands. So that's a huge fishery there. But then, of course, the United States has long coastlines in both the Atlantic and Pacific, and these are also substantial fisheries. Right off the coast of New England here, we have a rather substantial fishery. This brings up the issue of overharvest. With a steadily increasing rate of removing marine organisms from the ocean, we can expect that at some point the populations of these organisms can't keep pace with their rate of harvest. And we are indeed seeing this with a variety of different marine species. And to be sure, there have been a number of regulations passed to control harvest and to set limits for harvest. But because much of the ocean is in international waters, it's a free-for-all. And there are nations that don't abide by international regulation, and so it has led to what has been classically referred to as the tragedy of commons effect, where we have a common area which is available for everyone to use, but no one's really responsible for protecting it, so it tends to get overused. There's little motivation for controlling harvest size in these commons areas, and so consequently overharvest has been an ongoing problem. Within continental U.S. waters, it is a different story because there are regulations that are enforced to control the rates at which marine species are caught. And so that leads to sustainable fisheries. But outside of that jurisdictional limit, again, it's been rather a free-for-all. Here's a National Marine Fisheries Service graphic that illustrates the increasing rate of harvest of a variety of different species. And you can see that the rates just keep going up and up and up for a lot of these species. At some point, we can expect that reproduction rate will be outstripped by removal rate, and consequently the fish stocks can be expected to go down. Now, marine organisms encompass more than just fish, however. So species like various kinds of marine mammals have also been harvested. In the 19th century and well into the 20th century, many species were over-harvested. In the case of species like this humpback whale, with a low reproductive rate, it was rather easy to overfish these things. And so their populations plummeted. And because they have these low reproductive rates, it has taken a very long time for some of them to recover. Some of them are still recovering from the very heavy overfishing of earlier years. And in fact, there are certain nations that still carry on a certain amount of whaling and sealing and things like that. And they pose an ongoing threat to populations of some of these species. Seals have also been subjected to overharvest. These are actually sea lions, but all these kinds of marine mammals have been subjected to varying levels of harvest and overharvest. And again, because these large mammals tend to have low reproductive rates, they can suffer very quickly from being hunted. It is rather easy for humans to hunt these things to a point of their being endangered or even brought to extinction. Now, seals, dolphins, especially dolphins, and their relatives can be taken as a part of other kinds of fishery operations. So when these big nets are cast out in the ocean, they don't just necessarily catch fish, they can also catch dolphins. And this is a graph of what's called dolphin bycatch. In other words, dolphins that are caught as part of fishing operations. And often these things, because they're air-breathing animals, if they are tangled in these nets and they don't get to breathe, then they die. And so here is a figure that shows from the 1960s to about 2000 the levels of dolphin bycatch. Notice that it has declined over time as more effective kinds of mechanisms have been put in place for excluding these kinds of animals from being captured. And indeed, it's not just marine mammals that can get captured as a consequence of fishing operations. Marine birds can also be captured, and here is a graphic from National Marine Fisheries Service again, showing the rate of capture of that group of seabirds called the albatrosses, which spend much of their life over open ocean, and how long-line fishing can wind up entangling and otherwise leading to the death of these marine birds. Notice again that over time the rate has tended to go down as more effective kinds of procedures are put into place to avoid this from happening. Now, just like it is possible on the land to practice agriculture, it is also possible to do that in the ocean, or for that matter in freshwater. A whole field called aquaculture has developed around farming various sorts of aquatic organisms for the market. So, for example, species like freshwater fish are grown for release for sport fishermen, and that's what you see going on in this image here. But very similar kinds of pens can also be used to raise other kinds of species. Salmon can be raised like this for release into streams that then go down to the ocean and help to bolster wild stocks and also help to produce a population that will come back to these streams. Species like salmon are referred to as anadromous because they come back to the streams that they were hatched in to lay their own eggs. Even though they spend most of their life as a marine fish, they spend part of it as a freshwater fish. And there are a variety of species like that. In addition to fish, various kinds of crustacea can be raised using aquacultural techniques. Things like crayfish are raised in the southern parts of the United States. Freshwater creature, a distant relative of the lobster. In Asia, things like marine algae are raised using aquacultural techniques. So there's quite a number of different kinds of species that can be raised and harvested in this aquaculture kind of a setting. There are problems that arise, and some of the problems are very familiar to farmers who raise things on the land. Contamination with chemicals, pesticide contamination, disease problems, all those sorts of things can also become issues in aquaculture operations. Notice that in this image that there is netting over these tanks. These tanks are being used to raise trout, and that attracts fish-eating birds, herons and fish hawks and species like that. And so in order to keep them from eating up all the individuals that are being grown here, netting is strung over the tanks. Another issue that can arise from aquaculture is that once you domesticate species in an artificial setting, the gene pool of these organisms starts to change. So you get a domesticated gene pool. And if some of these animals get loose and start interbreeding with wild individuals, it can have an impact on the genetics of wild populations, perhaps making them less aggressive or less wary or more disease prone. A whole host of possible sorts of phenomena can happen. Here's another National Marine Fisheries Service graphic illustrating world production of aquacultural products. Notice that over time the amount has increased rather dramatically. And if you look at the bottom graphic, you notice that certain parts of the world are much more active in this industry than are others in terms of consumption. So North America, China, Australia are big consumers of aquaculturally grown organisms. Notice also on the upper graphic that not only has aquacultural production grown over time, but that China is by far the world's leader in production of organisms using aquacultural techniques. The U.S. has a very small presence in this field, although despite that it is rather significant. Crayfish farming is very big business in the southeastern U.S., for example. And pretty much every state runs an aquacultural operation to grow sport fish. So let's now talk in more general kinds of terms, rather than just focusing on fisheries. Let's talk about the issue of globalization, which is now the reality for all of us, that global distribution of products and global consumption of products is now the norm. There is an enormous amount of movement of materials about the planet, more so than ever in history. So all of the world's economies are now linked by this global interchange of goods, services, and so on. One organization, the World Trade Organization, has been instrumental in enhancing this global tendency. And there's also an international agreement, a general agreement on trade and tariff, which reduces international barriers to trade. The thinking has been that such globalization is good for everybody, because more jobs are created and new markets are open for producers and so on. So the feeling has been that globalization is an economic plus. However, as we've seen in the US, it's not all a plus. We've seen many jobs leave the US to other parts of the world, so there can be global shifts in employment patterns. So, for example, the textile industry in the US has largely shifted to other parts of the world. Another issue that has arisen is that countries that have more lax environmental pollution standards are often places where certain kinds of polluting industries move to, so those parts of the world are differentially affected by pollution and their populations suffer the consequences of that. China has been notorious for its lax environmental standards, for example, but they are hardly the only nation that is guilty of that sort of thing. In more recent years, China has realized that this is not necessarily the greatest idea, and they have started enacting more stringent environmental standards. The US did much the same thing in the 19th century, and England and other countries during the Industrial Revolution. All these countries during the early stages of their industrialization had weak environmental standards, which led to substantial public health issues. And so we are again seeing this sort of thing in parts of the world where environmental standards are weak. Now, we've taken a look at one kind of shared resource so far, fisheries, but there are a number of other resources that are shared about the planet, shared between nations and so on. So water resources such as aquifers, waterways, mineral deposits, things like oil deposits will often straddle boundaries between nations. And we can even talk about natural habitats, various kinds of ecosystems that cross political boundaries. And so, for example, in the case of Africa, there are a number of large mammals that migrate with no regard for international boundaries because the habitat straddles those. And so a lot of these large mammals move in and out of different countries. And as they do so, they may be subjected to differing laws in terms of harvest and things like that. So there has developed a body of international law to deal with some of these issues. And when nations have disputes about such things, they can go to an international body to have these disputes resolved. Here is another interesting harvest graphic showing the difference between recreational harvest and commercial harvest of striped bass, which is an important game species on the east coast of North America. And with that, we will conclude our topic of land and water resources and the larger topic of environmental science. It's a bit of a brief program today, but we have covered what we need to cover, and so we will end at this point. Stay tuned for other courses that you may want to take in the future that will also be offered in this format.